Hello everyone, today we are going to be doing some Blind 75 C++ Leetcode, and today we're working with Palindromic Substrings. So, to be able to kick things off or what we need to do, we first need to have our 4 questions laid out, asking ourselves what the input's going to be, what the data structure / algorithm / technique we need to use, what to do with the data, and what our output's going to be. So, first off, breaking down the question, to answer our question with the input, given the string s, so we already know exactly what our input is, we need to return the number of palindromic substrings in it. So a string is a palindrome when it reads the same backwards as forwards. A substring is a continuous sequence of characters within the string. So we need, it looks like, especially from example 1, where we have A, B, C, there's an output of 3. There are 3 palindromic strings, which are their own separate characters. And example 2, we have A, which has a combination of 6 different palindromes which can be made from this string. So return the number of combinations of palindromic substrings. And a palindrome is, as stated before, is when it reads the same forward and backwards. It's like damn it, I'm mad. Spelled backwards is damn it, I'm mad. Like same way. Just same amount of characters in the string accordingly, forward and back. Alright. And so this type of problem for palindrome dynamic programming is a popular technique that we would use for our solution. And I'm just going to go further in depth inside the steps of what we got to do. So breaking down, first thing we need to do is that we need to initialize the string length and the matrix that will have the string length on the inside to check to see if there is a palindrome. If so, it will be true. This may be a little bit confusing and for the first step, but what I mean by the first step to start is that we are going to be creating a matrix, and I will write this out after we go through the steps. So the first step we will do is that I'm going to have n be equal to s dot length right here, and then we're going to create our matrix over here. We're going to initialize our matrix where it's going to be a vector bool. Going to be a matrix accordingly where it is actually n, which is the size of our string, vector a boolean n false right here, and this will represent and n represents the size of our given string that we have, and we're checking to see by using this matrix throughout each of the steps that we will be doing, because we're going to be looping through our entire string to check for palindromes. We'll be using this to keep track of if there is a palindrome or not. Okay, so for the second step of what we need to do is that we need to create a count as well. And then for the third, we're going to iterate through our string s. Two. So I'm just going to do that. We're going to create our count to keep track of the number of palindromes on the inside, and first initialize, and then right through our string, we'll be iterating backwards and then iterating forwards. And while we're iterating backwards, we're going to set that our matrix to true to start, since we need to count for the single character that we will have. And then we'll increment our count for need to return how many palindromes are inside of our string. And then we're going to iterate forwards, and while iterating forward, our condition is going to be we will check to see if the character at index I, s of I, is the same as the character at index j, s of j. since j is going to represent the index that we will be going in a forward direction. And then we will be checking the length of the substring. Okay. And if the characters are the same, and if the length of the substring is 2, then it will be a palindrome. And 3 palindrome, and this part is just going to be one continuous line if statement that's going to have different parts of it. So I'm going to go back and then we'll further expand upon that part for 3.2.2. So let's just go back on 3. We're going to iterate backwards. So for int of I is going to be n minus 1 because we're iterating backwards. I is greater than or equal to 0, and then I is decrementing backwards accordingly, and then we are going to set dp for true right over here, and then we're going to increment our count, and then we're going to be creating our second for loop where j is going to be equal to I plus 1, referring to the next index that we're referring to. J is less than the size of the string, hence n right here. And j is incrementing as well. Then what we will be doing is that now continuing on the subsection for 3.2, we're iterating forward, is that we will be checking 3.2.1 is referring to s of I is equal to s of j. And this part, maybe a little bit tricky, is going to be j minus I, which represents the index in the forward and backward direction to see if it's 1, or the matrix that we have with our given index accounting for where our initial point is relative to our backwards point right here to see if there is a valid palindrome. If there is, then we're going to be returning true with respect to two different ones. Like for instance, if we have A right here or this one right here, or we can have BAB. We already know that I would represent this B and J would represent this B over here. And we'll increment our count. I have to reset this to true. And we have done so to keep track of everything. And then finally what we need to do is return the count. Let's highlight right here. Let's make sure we have everything already set in place. Make sure everything's already initialized. Right here, double check. I think we should be good accordingly. All right, woohoo! We passed all the test cases. Now, let me clean this up for you folks so that way you guys can get a better look of our entire solution. Awesome job. Woohoo, yeah. There we go. There we go. Bam. Right here. Step 1. Step 2. Step 3. Then step 4. There we go. Let's make sure it's all right. After all the cleaning, boom, we got it, and ta-da! And wow, that's pretty good. All right. Now, just to give a whole rundown over space and time complexity that we have for the following is that our time complexity, given the fact that we have 2 nested for loops to be able to start, but we are also given a string with a given amount of size. So given the fact we have a nested for loop to start, and this is accounting for scanning the array twice, we would have a time complexity of O of n squared. Now, mind you, since we also have a Boolean matrix that we are storing, one, the conditions as well as the characters, we will have a condition of O(n) squared. And the following solution is already efficient in terms of time and space complexity, since we're using dynamic programming to avoid any redundant computations altogether. So yeah, this was Palindromic Substrings. Thank you again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And also, if you have any questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye.